We did the two problems. We did 5 times the square root of 3 plus 3 times the square root of 3. We can add them together because they had the same radicand. That's what that's called, radicand. We treated them like variables, so we kept the square root of 3 and we added the coefficients in front to get 8 times the square root of 3. Then we also had 7 times the square root of 5 minus 2 times the square root of 5. They both shared the square root of 5. So we kept that just like it's a variable. And then 7 minus 2 is 5. Okay? Any questions about that? Does that jog your memory a little bit? Jog? Don't make me run. Don't make me run. All right, let's take a look at example 1. Add and subtract expressions with like radicands. All right, where do you see like radicands, like terms? Say it again. Yes, and give me the terms that are alike, specifically. Like which ones would you combine and put together? Go ahead. 4 times the square root of 5. You're going to put this one and combine it with minus 2 times the square root of 5. Yes, because they share the same radicand. That's what that's called, the radicand. So 4 times the square root of 5 minus 2 times the square root of 5. I'm going to combine those. So can I combine the other ones that are left? Ashley, can I combine 3 radical 7 plus 7 radical 7? Yes, because they have the same radicand of the square root of 7. So plus, always check the sign in front. That's a positive 3 radical 7 plus 7 radical 7. All right. So let's look at these first two. 4 radical 5 minus 2 radical 5. I'm going to keep the radical 5. It's just like a variable. And then finally, 4 minus 2 is 2. 4 minus 2 is 2. I should do that in a different color. Okay. Then we have over here 3 radical 7 plus 7 radical 7. Keep the same radical, which is the square root of 7. And 3 plus 7 is 10. 3 plus 7 is 10. Can I combine these two? No, because they don't have the same radicand. All right? So your final answer, 2 radical 5 plus 10 radical 7. Miss Dee Dee, could I write those so they were, switched around? Could I have 10 radical 7 plus 2 radical 5? Yes. Either one of those is correct. Okay? Let's see if you can do this one down below. Now, be careful because we've got a couple of subtraction signs, but see if you can simplify that expression. That is an expression. Go ahead and try that. Can I get rid of this for you? Or do you want to wait? Okay. Because you might not eat it. Oh, okay. You're done. Are they dry? Yeah. A little bit. That's too bad. Oh, you're welcome. See if you can put that one together. Do you have it? Oh, yeah, you do. Okay. I think it's page 18 for you. Let me just check this one real quick. Okay, I'm careful. 17 minus 3 is 14. Yeah, you got the hard stuff. Let's not miss the easier stuff. Okay, so when they are unlike, you're going to have to, take the square root of those and simplify those individually, like using the cake method or using the perfect squares, until you get a radicand that is the same. Then you can combine them, okay? All right. I love seeing lots of people working on this problem. How are we doing? Hi, good morning. Esmeralda, do you have her Chromebook? Okay. Okay, so which ones can I combine? Have a great day. Uh-huh. Which ones can I combine here? Edward, which ones can I combine? Can I combine any? I can't combine any? Don't I have some that have the same radicand? How about this one? 17 times the square root of 19. Is there another one with the square root of 19? Yeah, right here. So 17 times the square root of 19. Again, check that sign. Minus 3 times the square root of 19. Okay. And I'm going to keep that radicand. This is only when you're adding and subtracting. And 17 minus 3 is 14, right? What about these? Minus 14 radical 6 plus 11 radical 6. They have the same radicand. So minus 14 square root of 6 plus 11 square root of 6. Keep the square root of 6. And the coefficients in front. Negative 14 plus 11. Negative 3. Minus 3. So putting it all together, we have 14 times the square root of 19. That's a square root. Minus 3 times the square root of 6. Did anybody have that as an answer? Nice. Nice. Doesn't it feel good to get the math? Yes. Did anybody happen to have negative 3 square root of 6 plus 14 times the square root of 19? Because that would have been the same answer, only flipped around. You did that? Good. Good. All right. Example 2. Add and subtract expressions with unlike radicands. Of course. So now we have these two radicals. We're trying to add them together, but they don't have the same radicands. But we need to simplify them first. So let's use the cake method. So square root of 48. What kind of number is 48? Even, so I divide by 2. 48 divided by 2 is 24. 24 divided by 2 is, come on, help me out, guys. 12. 12 is even. 12 divided by 2 is 6. 6 is even. 6 divided by 2 is 3. 3 is not even, but it's divisible by 3. And we get 1. Whew. So these are all my prime factors that I need to rewrite under the radical sign. So I have 4 2's that I'm multiplying. 2 times 2 times 2 times 2 plus, hey, wait a minute. We could do square root of 12, but we just have the square root of 12 right here, right? So the square root of 12 is this much of it. Or you could rewrite it over here, right? Divide by 2 is 6. Divide by 2 is 3. Divided by 3 is 1. You get the same thing. So, plus the square root of 2 times 2 times 3. Oh, I forgot my 3, didn't I? Yeah. Sorry about that. So I forgot my 3 on the end of the square root of 48. Okay, we know if there's pairs, they get kicked out. So we have a pair of 2's. We have a second pair of 2's. Comes out front. 1 comes out front. We have 2 times 2 times the square root of 3. And we can simplify that. We know 2 times 2 is 4 times the square root of 3. Plus, don't forget the big plus here. Over for the square root of 12, I have a pair of 2's. That gets kicked out, so that's going to be 2 times the square root of 3. Put that down here. 2 times the square root of 3. Oh, but they have the same radicand. So now I can combine them. You keep that same square root of 3. And 4 plus 2 is 6. So final answer is 6 times the square root of 3. Does that make sense? Yeah, so we're just combining some of those steps. All right, let's go to the next page. Holy smokes. All right. Oh, Miss Dee, they're using larger numbers here. Yes, they are. Here we go. Let's look at A. It says simplify 3 times the square root of 75 minus 6 times the square root of 48. Can I combine those as they are? No, they don't have the same radicand. So put the 75 down. This 3 in front is just hanging out in front. So we just deal with the 75 for right now. 75 ends in a 5, so it's divisible by 5. 75 divided by 5 is 15. 15 ends in a 5, so it's divisible by 5, and that gives me 3. 3 is divisible by 3, and that gives me 1. So these are my prime factorization for 75. So I'm going to rewrite that as 3 out in front. That 3 is already out in front. We still keep that. Times the square root of 3 times 5 times 5. Okay? Minus, big minus here. Make sure we keep that separate. Then we have a 6 out in front. And I need to find the square root of 48. I'm going to use the cake method. Okay. Omar, what kind of a number is 48? Is it a nice number? Is it even? Is it odd? Yeah, it's even. So divide by 2. Good. 48 divided by 2 is 24. 24 is even. Divide by 2. You get 12. 12 is even. Divide by 2. 6 is even. Divide by 2. You get 3. 3 is prime, so we can divide by 3, and we get 1. Whew. It's a lot of numbers, Miss Thede. I know. So put them all down. We got 4 2's. 1, 2, 3, 4. Remember, we're multiplying all these together. Times 3. All right. I wish I had more space. I don't think I write that largely, but anyway. All right, now I need to circle my pairs. I got a pair of 5's. So the 5 is going to come out and be multiplied. So that's going to give me 3 times 5. And what do I have left? Just that 1 3. Okay? Minus, I'm going to do this over here. I've got a pair of 2's and a pair of 2's. I have 2 pair. So that 2 comes out. This 2 comes out. So I write the original 6 down. And times 2, that's the first set of 2's, times another 2. and I'm left with the square root of 3. Now I'm going to combine these all together. 3 times 5 is 15 times the square root of 3 minus 6 times 2 is 12. 12 times 2, 24. Jeez. Times the square root of 3. I can combine these because we are subtracting and they have that same radicand. So I keep the square root of 3. And 15 minus 24 is negative 9. So yes, you can have negative radicands. Man, that was a lot. Now this only happens when you are adding and subtracting them. You have to have the same radicand. Okay? All right. Let's see if we can get through. We've got 3 more to do. The last 2 are going to be easier. Let's do letter B. And can I erase this right here? Because I really need that space. I really, really do. All right. So negative 11 times the square root of 50 plus 2 times the square root of 32. Can I combine them as they are? Just say no. We can't. All right. So we need to do the cake method. 50. It's not a square root. We're just dividing. 50 ends in a 0, so it's divisible by 5. But maybe you said it was even. You could divide by 2. 50 divided by 5 is 10. 10 ends in a 0, so it's divisible by 5. You get 2. 2 is even. Divide by 2, you get 1. Okay? I'm going to do this other one really close because I think I'll have more room. So now I'm jumping over here. Square root of 32. 32 is even. Divide by 2. Tiana, you with me? You get 16. 16 is divisible by 2. You get 8. 8 is divisible by 2. I should have started lower, shouldn't I? You get 4. Divide by 2. You get 2. Divide by 2. You get 1. So I need to include all of these for the square root of 32. All right, so here we go. Negative 11 times 2 times 5 times 5. I usually like to write them in numerical order. Is that a plus in between? Mine's kind of, okay, thank you. Plus, then we have 2 on the outside. And the square root of 32 we can rewrite as 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's. Okay? Find your pairs. Here's a pair. Kick it out. Here's a pair. Here's a pair. Kick it out. Kick it out. So I have negative 11 times 5 on the outside. The only thing that doesn't have a pair is that 2, so that's times the square root of 2, plus, here's my original 2, times this first pair of 2's, that's the 2 from that, here's the second pair, and the only thing that I don't have is 1, 2 left there. So simplifying it, negative 11 times 5 is negative 55 times the square root of 2 plus 2 times 2 is 4, and 4 times 2 is 8 times the square root of 2. Are we done yet? Not quite. Now, they have the same radicand, so I can combine them. And negative 55 plus 8 is going to be negative 43 times the square root of 2. That is a lot, Miss Dee Dee. Is it 47? Oh. Good job. Sorry about that. 55 minus 8. Yeah, it is 47. I think I was taking the 8 minus the 5, but it's the 5 minus the 8. All right. That was intense. That was a wigwam circus TP intense. Get it? Intense? Okay. Oh, Miss Lady. All right. Let's now multiply. Multiply. Multiplying is so much easier. Okay? Because you don't have to have like radicands. You are going to multiply coefficient times coefficient. So 5 times 4. And when you are multiplying, oh, I thought that was a fire. Did you hear that? Kind of sounded like an alarm, didn't it? Okay. I thought it was something there. If they're under the radical and you're multiplying, you can put them both under the radical. So 5 times 4 out front is 20. 3 times 6 is 18, but guess what? 18 can be, the square root of 18 can be simplified. So we got to do the cake method for this. Oh my gosh. So 18 divisible by 2 gives me 9. 9 is divisible by 3, gives me 3. 3 is divisible by 3, gives me 1. So I rewrite these. 20, still on the outside, times 2 times 3 times 3. Now you have a pair of 3's. Kick that out. Remember, that gets multiplied. So that's 20 times 3 times the square root of 2. 20 times 3 is 60 times the square root of 2. Bada boom, bada bing. Whew! You know, I didn't think it was going to take this long to get through all this, but that was a lot. All right, so what is due tomorrow? Homework number 3. Homework number 3 is due tomorrow. And I'm sorry, it takes us this long to get through these practice problems. But you have your notes. Check back in your notes. And if they help you, hopefully they help you, you can get that help from your notes. Okay?